Welcome to the concept of mensuration of solid shapes in mathematics. So what is actually mensuration of solid shape is a branch of mathematics that deals with the measurement of geometric figures and parameters like length, volume, shape, surface area, etc. of solid shape. So this concept will be important or lucrative for those that are into construction of every form, those that construct gates, construct motor vehicle body, construct every sort of construction, can make use of the idea, the concept of mensuration of solid shape to understand exactly what they have to do any kind of construction. So the shapes we are going to be looking at are the major solid shapes we have in mathematics, such as cube, cuboid, cylinder, cone, sphere, pyramid, prism, etc. So these are some of the shapes we are going to be looking into to determine their volumes and their surface areas, and also some other parameters of they have, such as the radius, the length, the height of such shapes will be determined. Making use of these different examples, we are going to be able to know how to do the calculation or the mathematics involved in this mensuration. So going by the first question we have here, we are given that the diagram shows a solid cone. The diameter of the base of the cone is 24 centimeter. The height of the cone is 16 centimeter. The curved surface area of the cone is 2160 pi centimeter square. The volume of the cone is V pi centimeter cube, where V is integer. Find the value of V. So as given in the diagram also, we can see that the diameter of the cone is given as 24 s, and the height is given as 16 s. So that is the parameters we are given, and we are going to be making use of this with the value we are given as the curved surface area to find what we are looking for, which is the V, the integral value of V. So to do this, these are going to be our step. So we have that the height, okay, the diameter is equal to 24 s, which translates that the radius is equal to 12 x. The height is equal to 16 s. So we need the slant height, which is here. We need to find the slant height of the cone. So in order for us to do that, we have to establish from the vertex of the cone to the base of the cone, we are going to draw the height to the base and establish the base radius, which is r. Here is the height. So this constitutes a right angle triangle with this. So to find, since we know the value of the height and the value of the radius, we can proceed into finding the slant height. So you can, if you consider this triangle, this side L is the hypotenuse side of the right angle triangle. So according to Pythagoras theorem, we are going to say L square is equal to h square plus r square. So substituting the values, we have L square is equal to 16x square plus 12x square, which will give us 16 square. 16 square will give us 256 x square plus 144 x square. So that r square is equal to, adding the two together, we are going to get 400 x square. 400 x square is what we get from there. So that we can now go ahead and find the L. L is equal to root 400 x square, which gives us L to be 20s. So having found 20s, we can now proceed into finding the value of x. We need to use the formula for the surface area of a cone. Surface area of a cone is given by this a sub s to represent the surface area is equal to pi RL. Pi RL, where R stands for the base radius, while L stands for the slant height. So that is the formula for curved surface area of a cone. So substituting the value, which is actually equal to what we are given initially to be, we're given that to be equal to 2160 pi. 2160 pi. 2160 pi is the value of the surface area of the cone. So from here, pi can cancel out pi, and we have that r. Okay, we substitute the values of r and l. R is 12x multiplied by 20s is equal to 2160. So that when this multiplies together, 12 times 20 will give us, okay, we can cancel out, we can reduce it by this cancels this. As we now have 24 x square is equal to 216. So x square is equal to 216 divided by 24. So that will give us 9. So that x is equal to root 9, which is equal to 3. So having found that, we now proceed to find the value of v, which is the volume, the integral value of the volume. So we have v. Then to find v, we use the volume of a cone. Volume of a cone volume of a cone is given by 1/3 pi r square h, which is actually equal to, according to what's given, is v pi is equal to 1/3 pi r square h. Substituting the values, we have v pi is equal to 1/3 pi times 12s. 12s is the value of radius, but we have found s to be 3 times 3 square times the value of h, which is 16s, so 16 times 3, so that we have pi will cancel out pi on the both sides. We now have v is equal to 1/3 times 36 square times 48. That is 16 times 3, 48. So we now reduce by cancelling. 3 to itself is 1 and 3 to 48 will give us 16. So that we have v is equal to 16 times 3, 36 raised to power 2, which is equal to 16 times 36 raised to power 2. 36 raised to power 2 can be found by 36 times 36 equal to, that gives us 1296. So multiplying out, we have v to be equal to, using calculator again, when we multiply out times this value times 16, we have 20,736. 20,736 as the numerical value of all the integral value of v. So that is the value of v, the integral value of v. Volume of cuboid is given as v equal to length times breadth times height. As you can see, the values are given here. So v is equal to 3x times breadth, which is 2s, times height, which is x. So that v is equal to 3s times 2s times s will give us 6s cubed. But we are given from the statement that the total volume of the cuboid is less than 900. So we are going to set it in this way, that 6x cubed is less than 900. So this is what we are now going to use to determine this fact. So now from here we have that x cubed is less than 900 divided by 6, that is by dividing both sides by 6, and that will give us that s cubed is less than 150. Yes, because 900 divided by 6 will give you 150. So we now proceed to say that s, taking the cube root of both sides. If we take the cube root of both sides, we have s is less than cube root of 150, and S will give us is less than 5 points, around 5.313 when you check with your calculator. So from here you can see that what we get agrees with the range of x as given in the equation, because we are given in the equation that we should show that x is less than 5. So you can see that actually s is less than 5.3, or s actually from what we determine is 5.313. So in that case 5.313 is greater than 5, so it agrees with s is less than or equal to 5. So we are correct, or it has been proved. The third question, we are given, the question says a water tank is a cylinder with radius 40 centimeter and depth 150 centimeter. It is filled at the rate of 0.2 liters per second. That we should take 1 liter to be equal to 1000 centimeter cube, and we have asked that does it take longer than 1 hour to fill the tank. So to show the working out in this, from the diagram we are giving all the information that is spelled out in the equation. The radius, the height is given. So what we do first is find the volume of the cylinder. After that we convert it to liters and then use it to determine the time. So the volume of a cylinder is given by pi r square h. That's the volume of a cylinder. So substituting the values, we have V is equal to pi times 40 square times 150, and that will give us 22/7 times 16, or 1600 times 150. That is equal to using our calculator, we have 22 times 1600 times 150, and that will give us exactly 5,280,000 divided by 7. So that is in centimeter cube. That's in centimeter cube. So we proceed to convert it to liters. To convert it to liters, we know that 1 liter is equal to 1000 centimeter cube. So converting, we have 5,280,000 divided by 7 in centimeter times. We have to divide by 1000, 1 over 1000, and that will give us 5,280 over 7 liters. So that is in liters. Again, we are given that R, the rate of flow is 0.2 liters per second, and we also know that volume is equal to rate times time. So from here we make time the subject of the formula. That means T is equal to V over R. So making our substitution, V we have it to be 5,280 over 7, 5,280 over 7 divided by the rate, which is 0.2. The rate is 0.2, so we are going to use it to divide that, which will give us T to be 5,280 divided by 7 times 0.2 will give us 1.4, and that will give us, with our calculator, 5,280 divided by 1.4 is equal to, is around 3,771 points, some fractions, let's say 43. So that is it, seconds. So this is the time it will take the cylindrical tank to be filled with water. But the question says, does it take longer than 1 hour to fill the tank? Does it take longer than 1 hour to fill the tank? And the answer will be, since we are talking of 1 hour, this is in seconds. In an hour, our time in hour will be around what? 1 point something. Around 1 point. When you divide by 3,600, I'm going to have it in about 1.285 hours. So 1.285 hours and 1 hour. So actually the answer is yes. It's going to yes. It is going to use more than 1 hour. So it's yes. The next question says that a solid metal sphere has radius 9.8 centimeter. The metal has a density of 5.023 grams per cm cube. Lian estimates the mass of this sphere to be 20 kilograms. Show that this is a reasonable estimate for the mass of the sphere. So we are asked to show that that is a reasonable estimate. That means we have to find the volume. After finding the volume, we go ahead and find the mass. So we are talking of a sphere here, and we are given the parameters of the sphere. The radius is given. That's the major parameter of a sphere, is the radius. The radius is given is 9.8 centimeter, and we are also given the density of the sphere, the material used in making the sphere. The density of the sphere is 5.023 grams per cm cube, and the estimated volume mass by Lian is 20 kilograms. So to find the volume, we make use of the formula of a sphere. Volume of a sphere is given as 4 over 3 pi r cube. So substituting the value, V is equal to 4 over 3 pi times the radius, which is 9.8 raised to power 3. So moving on, we have that to be equal to 4 pi over 3 times finding the value of 9.8 cube. 9.8 cube with your calculator will give you around 3,942.456. So simplifying completely with your calculator again, I'm going to get the value to be around 3,943. Sorry, that was a slight mistake here. Using our calculator to find 9.8 times 9.8 times 9.8 equal to, that will give us around 941.192. 941.192. 112. So that is the value. So that when multiplied out, it's going to give us, everything will give us around 3,943, 3,942.456 centimeter cube. So we now proceed to find the mass. The mass is related to volume and density, as mass is equal to density multiplied by volume, so that the mass is equal to the mass of the object can be found to be the value of the density. Value of the density was given as this, that is 5.023 times the value of the volume just found, which is 3,942.456. So when multiplied out with a calculator, let's use a calculator to multiply it out. 5.023 times 3,942.456 gives us around 19,802.956. So this is in grams. Now m in kilograms has to be 198.02.956 divided by 1000. Why? Because we know that 1 kilogram is equal to 1000 grams. 1 kilogram is equal to 1000 grams. So we have to divide, to convert from grams to kilogram, we have to divide the value in grams by 1000, and when that is done, we are going to have around 19.803 approximately in kilograms. So from what the question is asking, say show that this is a reasonable estimate. That's 20 kilogram is a reasonable estimate. So 20 kilogram is actually a reasonable estimate, because if we want to approximate this to the nearest whole number, we are going to have it as 20 kilograms. So 20 kilograms is a reasonable estimate. Thank you. The next question is talking about a hemisphere. said that what the diagram shows a solid hemisphere. The volume of the hemisphere is 250 over 3 pi. Work out the exact total surface area of the solid hemisphere. Give your answer as a multiple of pi. Hemisphere is half of a sphere. Hemisphere is a half of a sphere. A sphere cut off from the middle. So that is what hemisphere is. So to solve this problem, we write out the parameter we are given. The major thing we are given there is the volume. The volume is equal to 250 over 3 pi. So in order for us to find the total surface area of the sphere, we need to find the radius. So we are going to use this value with the formula of the volume of a sphere to find the radius involved. So the volume of a sphere, V, is given by 4 over 3 pi r cube. But we are talking of a hemisphere, so we are going to divide by 2. So that will give us 2 over 3 pi r cube. So two pi r raised to power 3 over 3. So that's the volume of a hemisphere. So V is equal to that gives us we substitute the value of the volume of the hemisphere, which is 250 pi over 3 is equal to 2 pi r cube over 3. Pi cancels pi, 3 cancels 3. So we now have 2 r cube. 2 r cube is equal to 250. That means r cube is equal to 250 divided by 2. R cube is equal to 125, and that's done. So that r is equal to cube root of 125, and that will give us exactly 5. So 5 centimeter is the radius of the hemisphere. So we are asked to find the total surface area of this hemisphere. Total surface area of the hemisphere is given by pi r square for the base radius plus for the base area plus the curve area, which is 2 pi r square. So that will give us 3 pi r square. So that will be equal to, substituting the values we have 3 pi times 5 raised to power 2, which gives us 3 pi times 25 it gives us 75 pi. 75 pi centimeters square. That is total surface area of the hemisphere is equal to 75 pi centimeter square.